Okay, sign convention for spherical lenses. Okay, so spherical means round, lenses means both the sides, lenses will be there like glass, it will be there, it is the transparent. Okay, so for lenses we will use a sign convention similar to that used for the spherical mirrors. For spherical mirror, and we also use the same rules. The measurement in case of mirror was taken from the pole of mirror. Okay, so here also whatever rules we used for the spherical mirrors, the same things we use for the spherical lenses. And also distance, and whenever we measure the distance, it will be from the optical center O. For the concave and convex mirrors, it will be from the pole point. Whatever we measure, it will be from here. Okay, so if the image is formed, if the object is on topwards, it is the positive. When it is the downwards, it is the negative. Okay, and if it is in the, if the object or image is forming this side, it is the positive direction, and this side it is the negative direction. Okay, so sometimes as we see, okay, so for this also the same thing. Okay, length upwards positive, downwards negative. If the image is formed like this means it is the negative, if it is means it is the positive. So these images, always upside down images, are called as a real images, and another one real images, and here this one always will be the negative. And virtual images are always positive, and they are virtual images. Okay, these are called as what? Virtual images. And another one, erect. Erect means straight, it will be the straight. So this is the one. If this one is formed this side means it is the positive direction, and direction is the positive, and length upwards and downwards, it is the negative direction. Okay, so we mostly concentrate on this one, positive and negative. Okay, so downwards, and these are the signs convection, giving the positive sign and negative sign. And mostly always the virtual images are erect, in a straight, so like this, straight. So this always is the positive. Real images always upside down, it is inverted, so inverted always will be the negative. So these are the sign conventions. Okay, and here, and also we have some more rules are there. Okay, so the first one, what will happen the ray light traveling along the principal axis and as it gets refracted by the lens. Okay, so here if the ray is passing through the principal axis, when ray passes in the principal axis and afterwards it will be refracted. Refracted means bending. Okay, then next one, convex mirror, and like that only concave mirror also, what will happen there? Light passing through the optical center. If the light is passing through the optical center, what will happen? So like that. And if the ray is passing parallel to the principal axis and afterwards refracting when it passes through the lens. Refracting means bending of light. Always you observe this one in the convex, bulging outside means vex, convex lens. When it is coming this side and when it is bending, always it meets at some point. But in the case of a convex lens, it will be bending and diverging. Okay, and this diverging ray, reflected ray, will show as though it is coming from the focal point. Okay, so that one. And so here also the same thing. Okay, light traveling through the focus. F means the focus point, light traveling through this. And convex mirror also same thing, diverging. Okay, not meeting, but always it will show as though it is coming from the focal point. Okay, so here you see focal plane. Think about another situation. What will happen to a parallel beam of light passing through the lens? It is inclined at some angle to the principal axis. In this case, the light rays will appear to diverge from a point on the focal plane for convex lens. The light rays will converge at a point on the focal plane for convex lens. So when we see here, actually, for example, you see the parallel beam of light means so many light rays parallel to each other. Beam of light, so many lines, so much light. is coming, refracting, bending and meeting at one point in the convex lens. But after this it diverges at the focal plane. Okay, so it will be diverging. Then in the case of a convex lens, coming at a optical center and diverging. Okay, but all the rays it will show as though everything is coming from the focal point. Okay, so it will be converging at one point. Understand? So that is the one. Appear to diverge from a point on the focal plane for concave lens. Okay, but the light rays will converge at a point on the focal plane for convex lens. Okay, so in the convex lens all the rays are meeting at one point at the, this is the F now, this is the focal plane. But in the case of a concave lens it will be diverging, but although everything will show it is coming from the focal plane, diverging from the focal plane it will show, and it will show everything is converging at the focal plane. Okay, so image formation by the lenses. So how the image is formed by the lenses? So convex lens are always what? Converging lens, but convex mirror is diverging, convex lens is converging. Okay, so if the light is coming from here and meeting at this point means, so this light we can see this side. Upside down means what? Upside down means it is the real image. Okay, real image, and it is the negative. Okay, so if the object is here and formation is here, okay, understand, where the rays are meeting there only the image formation is there. Okay, so it is here, the image formation will be very far at the infinity out of the principal axis. And then here you see object is at the F1 and where the image is forming behind the F2. So these are the ways. I will post a video for your more understanding. Okay, so for the concave lens you see diverging. Okay, but this diverging ray will show, reflected ray will show as though it is coming from the focal point. So here also the same thing. Okay, and one more thing, in that lesson, in the convex and concave mirror you studied about the mirror formula. Okay, very important, but it is not very clear, I am very sorry. So here you see in the mirror formula. Okay, so okay, mirror formula, understand. So mirror formula, how do we take? Object distance is u, image distance v, focal length of the lens f. Okay, object distance and image distance means what? So for example, this is the which lens we take as a, for example, convex lens. This is the principal axis, optical center, focal point and center of curvature f1, and here f2 and c1 and c2. Okay, for example, object is here. Okay, object is here, the real candle na, so candle is here. This candle we can see here, understand. So we are able to see here, we are able to see here. So this is the object distance is u and image distance is v. All the distances are measured from the O, optical center. It is measured from there. Okay, so from the object to the optical center distance is u, and from the focal point to the, from the image to the optical center is small v, and the focal length of the lens, so the focal length is small f. Okay, lens, this is the formula. So here, so that is why, how do we take means between. So here it is not clear properly. So here 1 by v minus 1 by u is equal to 1 by f. Okay, so the above relation holds true for all spherical lenses. and in all cases of image formation. While solving the questions, take care about the proper signs of U, V, F. That means the image is upwards means real image, virtual image means plus, and down means negative. That means real image. These are the signs. Be careful about that. Okay, that one they are telling. And then here we say 1 by V minus 1 by U is equal to 1 by F. But in the case of a mirrors, formation of mirror formula for the mirror, it will be different. 1 by V plus 1 by U is equal to 1 by F. This is for the spherical mirrors, mirror formula. This is lens formula. 1 by, don't forget what is the formula for the spherical mirrors, means 1 by V plus 1 by U is equal to 1 by F. What is the formula for the spherical lens, means 1 by V minus 1 by U by 1 by F. Okay, and magnification means the height of the lens. Okay, the size of the object or image. Okay, so here M is equal to magnification. Okay, so what is the magnification means? Please write here or underline. Magnification means the ratio of the height of the image to the height of the object is known as a magnification. Magnification means what? The ratio of the height of the image to the height of the object is known as a magnification. Okay, for example, here we see. So height of the image. So M is equal to height of the image. H dash is equal to height of the image, and H is equal to height of the object. So height of the image is what for a small v. Height of the object is small u. Okay, v by u. Understand? So this is the one. So if the height of the image is 5 and height of the object is 10 means 10 divided by 5. Okay, so 2 times. Understand? So 2 is the, what is that, magnification of the this one. Understand? So this is the ratio. Understand? So ratio means what? The height of the image and the height of the object is called as a magnification.